Welcome back students to the next module of the chapter which is there. Here we are basically doing the expression of first law under various conditions which are there. Now let's recall what's the mathematical expression for first law of thermodynamic. It says as delta U is equal to Q plus W. So we have to see this equation under different processes. The first process is isothermal, it is adiabatic, isobaric and isochoric which are there. Let's take the first one, that's isothermal process. Now in isothermal process, don't you know the process in which temperature remains constant? If temperature remains constant, delta T is equal to 0. If delta T is equal to 0, delta U is also equal to 0, and if we substitute this value in the above equation, we will get 0 is equal to Q plus W. That means either W is equal to minus Q or Q is equal to minus W. Let's take the second process, that's adiabatic process. Adiabatic process is a process in which the heat exchange is not there. That means heat is not allowed to enter or leave the system which is there, which basically means Q is equal to 0. If we substitute that value in the above equation, we get delta U is equal to 0 plus W, which is nothing but delta U is equal to W. Let's take the third expression, that's isobaric process. In isobaric process, the pressure remains constant. That means delta P is equal to 0. But delta P value we cannot directly substitute in the equation. So we have to get the formula of work done. And what's the formula of work done? It is very simple, as W is equal to minus P delta V. Suppose we substitute this equation in the above equation, we'll get delta U is equal to QP, because now it is done at constant pressure, minus P delta V which is there. But here in the equation it says P delta V, whereas in isobaric process change in pressure is 0, but there is some pressure. That means the equation remains as it is, and we get delta U is equal to QP minus P delta V which is there, and this is nothing but the final change in internal energy. The last process, that is isochoric process. In isochoric process, volume remains constant, and if volume remains constant, that means delta V is equal to 0. Directly, once again, we cannot substitute this value in the above equation, so we have to once again take the help of work done, where the formula is W is equal to minus P delta V. Let's substitute that formula. We get delta U is equal to QV plus something called as bracket minus P delta V. Now delta V is equal to 0. If we substitute that value in this equation, we get delta U is equal to nothing but QV. That means change in internal energy can be also called as heat content of the system at constant volume. So this is nothing but the expression of first law in various conditions. Let's quickly go through certain MCQs which are there. Let's take the first one, that is, which of the following statement is incorrect? The first one is, for isobaric process dP is 0, for adiabatic process Q is 0, for isothermal process dt is 0, or for isochoric process du is equal to 0. Now we have already done this in the earlier modules. Let's take a quick recap. Can I say in isobaric process dP or delta P is equal to 0? That means first option is correct. Second option, that is for adiabatic process, if you see carefully, Q is equal to something called as 0. For isothermal process, delta T and delta U both are 0. That means dt is also equal to 0. That means for the fourth option, that is for isochoric process, if you see carefully, only something called as delta V is 0. That means du is not equal to 0, and that is why the incorrect option is option D, which becomes our correct option. Let's take the second question. Question says, in isochoric condition, change in internal energy can be also called as heat content of the system at constant pressure, or at constant volume, or none of these. Now here we have done, in isochoric process delta V is 0. Substituting that in the formula, we get delta U is equal to QV. That means the change in internal energy is called as the heat content of the system at constant volume, to be specific. That means option C is nothing but correct as far as the question goes. Let's take the third question. Question says, in which of the following process W is equal to minus Q? And we have been given four options as isobaric process, adiabatic process, isochoric process and isothermal process. In isobaric process, if you have seen the module carefully, delta P is 0, but somewhere W is not equal to something called as minus Q. That means option A is wrong. In adiabatic process, it's nothing but Q is equal to 0. Whenever Q is equal to 0, delta U is equal to W. That means it doesn't match our requirement. The third option says isochoric process. In isochoric process, delta U is equal to QV. Once again, it doesn't match our requirement. And in the fourth process, it's nothing but it says that isothermal process. Yes, in isothermal process, temperature is constant, so delta T is 0 and we get the value as W is equal to minus Q or Q is equal to minus W. So yes, this is where our option is basically correct and our final option is option D. This is what we'll be covering in this module. Till that time, thank you.